Okay. So an ellipse is the collection of points in the plane whose distance from two fixed points those are called foci, two fixed points, add up to a constant. And just like our low-tech demonstration, what is that one constant number? How long is that one constant number? How many A's? 2A. Yep, 2A. Foci are two fixed points on the interior of the ellipse. Are two fixed points on the interior of the ellipse. Major axis is the line containing the foci. Minor axis is the line through the center. And perpendicular to the major axis. And then center is the midpoint of the major axis or the minor. By the way, what's midpoint formula? Midpoint equals Yep. Averages of the x's and average of the y, okay? All right, vertices. We have two for the ellipse. So vertices are 2 points. 2 points of intersection of the ellipse and major axis. Okay, I'm gonna wait for you guys. I don't want to run too fast. Okay, length of the major axis is the distance from one vertex to the other. And it's always what? How many A's? 2A. That long or one? Okay. Okay. The following 4 definitions are here, so we can apply it to all of the applications in your homework. Whispering galleries are domes that are that are constructed in a way that sounds produce at any certain point are clearly audible at another location. And the reason is in the ellipse is because it probably has to do with the foci. All right, next three. The fact that the orbit of a planet about the sun is an ellipse with the sun being at one focus, okay? So aphelion, when a planet is furthest from the sun. And we'll draw a picture to go with that because that's kind of more difficult. So we'll do these three images right here. So here's an orbital path in an elliptical sense. And it says the sun, it's one of the foci, so that's focus one. On these problems, we're going to make your center at the origin, so it's just easier. And this one says, aphelion is the distance that's furthest from the sun. So that means the planet is over here. So this, the whole thing here, guys, is aphelion, okay? Right. Perihelion, when a planet is closest to the sun. So that means in our application, this right here is the shortest distance. So this is perihelion. Then mean distance of a planet from the sun. So the mean distance is kind of like what it sounds, okay, an average. So is the length of semi-major. Semi means what? Half. So half of your major. Remember, your major is the entire length from one vertex to the next. So this is vertex 1 and this is vertex 2. This right here is your mean distance from here to here. So it's half of your major, meaning that it's a value of A, okay, 1A. Okay, so those are all of the vocab that you would need. We have 2 theorems, so I'm going to wait for you for a little bit to fill in those 2 theorems, okay? All right, first theorem says we're going to write an equation of an ellipse with the center being at 0, 0. So this is easier. So here's the center. Oh, that's fat. At 0, 0. Major axis is along the x-axis. So that means the vertices. Major axis contain the vertex 1 and vertex 2. So this looks like, so center 0, 0. Major axis is there, so I'm going to make 2 more dots to get our ellipse. So this is the most basic equation of our ellipse. Based on our low text, this is F1, this is F2. Question number 1. The distance from the center to one of the foci is what variable? C. The distance from the center to this right here is B. We know for sure the distance from here, one vertex to the center is what? A. It's A somewhere else. Yep, A is also there. Okay, and this is always a right triangle. All right, with that said, we are going to fill out, we know the center is given to us. We are going to fill out the foci, the order pair of the foci. We will fill out the order pair of the vertices. And then the equation. Okay. All right, guys. Center 0, 0. We are looking for focus 1 and focus 2. What will change? X's or Y? Yep. Okay. So to get focus 1, how do we get there? Yep. So focus 1 is going to be, and then focus 2 is on the right side, that's +1. Focus 1's on the left, so it's -C. Okay, so pretty much we go in and add C and subtract C. Would you agree with that statement? And yes, you can move F1 and F2 around. Does that make sense so far? F1 doesn't have to be on the left, F2 doesn't have to be on the right. You label it however you want. How about vertices? What are we adding or subtracting? A, you're right. So plus or minus A, comma, 0. Perfect. Now, we are going to come in, because it is a right triangle, the Pythagorean theorem formula is going to be A squared equals B squared plus C squared. And as you can see here, the A distance, since it's from the center to one of the vertices, is always going to be longer than the B distance. Okay? And that's all. So A is always bigger than B, which will be positive because they are distances. Okay, that leaves us to our equation. Here we go. The equation for this is going to be x squared over A squared plus B squared over Y squared. And ellipses will always, always, always be equal to 1. This is the formula. Oh, I'm sorry. Oh, Y squared over B squared. Switch those. Y squared over B squared. I lie. Okay. All right, now I'm going to ask you a question really quickly. What do you think, what shape do you think it's going to be if A squared is exactly the same as B squared? A circle, yeah. So the distance here and here would now be exactly the same. Okay. All right, theorem number 2 says an equation of an ellipse with a center at 0, 0 again. This time, the major axis is along the y-axis. So let's draw that. Here's center. Here's vertex 1. Here's vertex 2. Let's make these over here. Okay, so here's the shape. Remember, the foci will always be along the major axis. So we'll call, oh, that's a fat looking pen. So we will always have the foci along the vertices. Okay, same thing. We are going to fill in foci, order pairs, vertices, order pair. Okay. Similarly, from the center to one of the foci, what is that length called? C. From the center to the minor axis, that length is called B. And then this is to connect that, so that's always A. Doesn't matter the position. Those will always be the same. And remember, A is also from the center to one of the what? Yep, that's also A. All right, now look at that drawing. Can you tell me, oh, it's always jump on me. All right, come on. All right, can you tell me how to label the foci? Are we changing y or x? Y, right? So x will stay the same as 0. So y will be what? Plus or minus c. Then same thing with the vertices, right? With the plural here. X will stay the same. Y will get plus or minus what? A. Pythagorean theorem, has it changed at all? Nope, because a is still the hypotenuse. So a squared equals b squared plus c squared. Has the length changed between a and b? No. A is still bigger than b. Can you see all of that is still the same? So for this one, I'm going to call this vertically positioned, okay? Because it's more up along this, it's more up and down. And then the previous one, I'm going to usually call this horizontally positioned. Now I'm going to give you the equation for this, and then we're going to compare. So the equation for this is going to be x squared over b squared plus y squared over a squared equals to 1. All right, and then we're going to compare the two, and then you tell me, how do I know what's what? So those are the two equations for ellipses, because one is positioned horizontally. The first one's horizontally, and the bottom one's vertically. At the end of the unit, usually they're all merged together. So by looking at just the graph, just the equation, how do we know the position of your ellipse? Sean?
Since B is shorter than A, right? A is on the y-axis now, so it's under the y.
Yes, that is very true. A squared, students, it's always bigger than b squared, always. Okay, because of A is bigger than b. So whatever it is bigger, and the variable that is under, that's the position of the ellipse, without even drawing it out. Okay, so A squared is bigger, it's under y squared, therefore it's vertical. Same thing here, A squared is under x, so it's horizontal. Okay. Let's go do examples. Oh no, not yet, I lie. Let's define when it's not at 0, 0. All right, equation of the ellipse when the center is h comma k, that means it's not at 0, 0. Major axis is parallel to one of the coordinate axes. So this way we'll start with the center being h comma k. We'll plot it right here. There's center. H comma k. Major axis, the first one, we'll make it parallel to the y-axis, maybe. To y-axis, like that. All right. So major axis. So that means I'm going to go up a bit, down a bit. These are my vertices. Okay. And then just slightly to the right and left to make a graph. Okay. Then we're going to go in and fill in the foci. We'll do this one as F1. This one's F2, definitely not scale. Okay, so from here to here is what variable? C. Perfect. From here to here is always B. Then the hypotenuse is what letter? A. And that means this whole chunk is also A. All right. Remember, just like the parabolas, right? I said don't memorize these. Try to visualize it. Okay. We know for sure the center is h comma k, whatever that may be. How do we write the order pair for the foci? What are we changing, x or y? The y, right? So would you agree that h stays the same? Okay, so we're going to write h comma something. Okay, and then k, plus or minus what? For the foci? C. Yep. Perfect. Vertices is exactly the same, except that k will do plus or minus a. Now the equation for this, would you agree that this is vertically positioned? And based on Sean's theorem, if it's vertically positioned, which variable gets the a squared? The y. Okay, so we're going to go in and go, okay, x minus h quantity square over something plus y minus quantity square over something always equal to 1. But we said the y will get the a square. Okay. And the Pythagorean theorem, guys, is still the same. A square equals b square plus c square. And a is always, always bigger than b. None of that is changed. All right, then the next one, we'll do something similar except it's horizontal. Is it wise to memorize this stuff? No, your brain's going to be exploding by the time we take second semester test, okay, final. So don't memorize, visualize it. See, oh yeah, I'm adding this value. All right, again, h comma k, somewhere. You want to be on the top or the bottom? Doesn't really matter. What's in the bottom? It's probably have more space. And this one, we're going to say that the major axis is going to be parallel to x-axis. So my vertices will be here and here. Okay, so I'm going to go up a little bit to draw. All right. Focus 1, let's just say it's over here somewhere. Focus 2, it's over here. From the center to one of the foci is still C. From the center to the minor, it's still B. The hypotenuse is always, always A. Okay. And this distance, students, it's also A. All right. Let's label the foci. How do we find the foci? What is changing? X or Y? X is moving. So this time it's H plus or minus what? C. Yep. And then same thing for the vertices. H plus or minus A. Yep. Okay, equation. Since it's horizontally positioned, which one's going to get the A square? X. Yep. X minus h quantity square over a square plus y minus k quantity square over b square. All of this should always, always equal to 1. Pythagorean theorem, same. And a distance is still bigger than b distance. Okay. All right, those are all of the possible formulas for ellipses. Let's do examples. Example 1. Verl, can you help us read the instruction?
Find the center, vertices, and foci of the ellipse. Graph each equation by hand.
Good. All of these would be done by hand. X squared plus y squared over 16 equals to 1. How come x squared doesn't have a denominator? Because it's 1. Yes, you can write 1. You don't have to. Doesn't bother me. First is to find the center. So what is it? 0, 0. Yep, plot it because we had to graph it by hand anyway. Checked. Ooh, okay. Do we know a square, students? What's a square? 16. And that's under which variable? Y. So how is this going to be positioned? Vertically. B square, Saba. What's B square? Good. So if a squared is 16, students, a would be what? 4. Can I go up 4, down 4? Yep. 1, 2, 3, 4. Vertex number 1. 1, 2, 3, 4. Vertex number 2. And then if b squared is 1, b is 1. So we're going to go to the right how much? 1. To the left how much? 1. And that is all you need, students, to graph. You don't need the foci for graphing. You just need A and B to make your ellipse. So graphing, we're done. Now we just need to find the rest. All right, we got A, we got B. Kristen, what formula should we use to find C? What Pythagorean theorem formula? Ooh, A squared equals? Okay, good. All right. Anika, what is a square? Good. Equals, Michael sign here, equals Billy, what's b squared?
1.
Perfect. All right, we're going to move 1 to both sides. C squared equals 15. So C is square root of 15. That is in its simplest exact form, so leave it. All right, let's find the center. It's found. Foci. How do we write the foci? What are we moving? Y or X? Y. So the X stays the same. So, Brayden, what do we write for the Y?
0, 5, graph 15. Or plus or minus, right? 15.
Perfect. You can write it twice, but you can also write it like that. Good. All right, Eve, we are looking for the vertices as well. Can you give us the order pairs for the vertices?
So then 0 and positive negative 16.
Awesome. Are you sure it's 16?
No, 4.
4. Much better. Good job. All right, guys, it's asking for all those 3. Box those up or highlight them if you have a highlighter. Let's do B. B says 5y squared plus 8x squared equals to 40. Is that equal to 1, y'all? No. So how do you make it equal to 1? Yep, everyone divide by 40. All right, Dana, if we divide each and every term by 40, what is now our standard form? Y squared over what? Plus? Beautiful. Perfect. Can you guys see that it doesn't matter y goes in the front? It doesn't matter. It's addition. It's commutative, okay? All right, center, because it asked for it. So what's the center? 0, 0. Plot it. Okay. Do we know what a squared is and b squared is? What's a squared, Katie?
2 rad 2.
Oh, I love it. But I'm going to write 8. I think you're looking for a. Right. A would be rad 8, like Katie said. But rad 8 is 2 rad 2. All right, we do need to plot it, guys. First, position. Vertical or horizontal? Vertical. How do you know?
A is larger.
Right. A is larger and it's with the y. So you don't have a calculator. How do you know how much up and down to go? What's rad 8? About? More than or less than what? A little less than 3. Yep. Go a little bit less than 3. Totally fine by me. Vertex 1. Vertex 2. B squared, Allie, is what?
5.
Yep. And then B is what then, Allie?
5.
Great. We don't have a calculator. How do we know how far out to graph? A little over 2, because rad 4 is 2, rad 9 is 3, so slightly over here. Is that all we need for graphing, guys? Yep, that's all we need for graphing. All right, we are done with the graphing. Are your ellipses nice? Okay, we do need to find C because we do need to find your foci. So, Sophia, what formula are we using to find C?
A squared equals b squared plus c squared.
Yes, a squared equals b squared plus c squared. All right, that allows us to say a squared is what, Emily? No, Emily's not here. Carter, a squared is what? 8 equals. B squared is what, Josh? Josh not here, so CC. 5. That gives us c squared. So c squared equals 3. So c is rad 3. Okay. All right, then we should be able to find the foci in the vertices, and we'll box those up. All right, to find the foci, what's moving? X or Y, Nathan? Y is moving, so X stays the same. Is that okay? For the foci, it will be adding and minusing what, Nathan? Perfect. Good job. Then vertices, remember Y is moving, so X will stay the same. And then Miss Lou, we're going to add or minus what to get our vertices? And what's your K value? Perfect. So it's just going to be plus or minus 2 rad 2. Box that up, guys. All right, here is C for cat. All right, Cami, help us read letter C. Great. Now what? You see this? What should you do? Complete the square. You're right. Oh, come on. It moved on me again. This is a pain. All right. Okay, so to complete the square, students, we are going to move all the x. Oh, are you serious? No, come on. We're going to move all the x's together and then the y's together. Okay, so 4x squared plus 8x plus a blank space plus 3y squared minus 6y plus a blank space equals 5. Okay, so we got to move all the x's together and all the y's together. Now, before we can fill in the blank space, we have to make sure the leading coefficient is 1. So we will factor out 4 from the x's, and we will factor out the 3 from the y. All right, if we take out 4, what's left? X squared plus 2x plus a blank space. Over here, very similar. Y squared minus 2y plus a blank space. All right, let's see if you guys remember what to do in the notes. All right, blank number 1. Bella, the first blank. What are we adding in that first blank? 1. You are correct. But students, whatever we add to the left, we have to add to the right. But technically, we're really adding what? 4. Yep, okay. So this has to be multiplied. And then over here, we're going to go at 4. All right, Devin, blank number 2. What are we adding? 1, but technically on the right side, we really add what? Perfect. All right, beautiful. So this is now 4 times x plus 1 quantity square plus 3 times y minus 1 quantity square. On the right side, it's going to be what, Matt? 12. We can't have it equal to 12. We have to make it equal to what? 1. So, Sean, how do we make this whole thing equal to 1? Yep, everyone, divide by 12. And then now write it in our standard form. Okay, x plus 1 quantity square over, Sean? Y minus 1 quantity square over 4 equals to 1. All right. We have to do all of that before we can even find what they want us to find. We will start with the center. So the center for this one, Jordy, is? Negative 1, comma 1. I'm going to go plot it as we go along. Negative 1. Okay, got the center. Let's find a square. A square is what? What's a square? 4. That means a is 2. Ooh, by the way, how is this positioned? Up or down? I mean, up or down. I meant horizontally or vertically. Yeah, so can I go up 2, down 2? Okay. I need more check marks in the bottom. Up 2, down 2. All right. So b squared is going to be 3. So b is going to be square root of? Without a calculator, students, how do I know how far to go? A little bit less than what? 2 units, right? So I need another tick mark here on the other side. All right, a little bit less than 2. So a little bit there. Somewhere between, 1 unit and 2, I'm okay. You don't have to be like, oh, 2.0. It doesn't matter as long as your tick mark is not in between. How come this looks so much like a circle? Because a squared and b squared, are they pretty close? Yeah, the closer they are, the more circular it's going to look for us. We do need to fill out, guys, the foci and vertices, so we do need to find the c square. So a squared equals b squared plus c squared. A squared is 4. B squared is 3. Ooh, c squared is going to be what? 1. So that means c is 1. Awesome. We have the center already. We just need to find 2 more, and then we can box it up. Foci, we have to have 2 parentheses, guys, because we no longer do plus or minus because they're not exactly the same number anymore. Okay, we know it is vertically positioned because the 4 is bigger than the 3 and the 4 is under the y. So what's changed? X or y if it's vertically positioned? Y. Y is changing. That means X should be exactly the same as your center. True or false? Yeah, we'll fill that in. At least you get points for that. Okay, we're going to take what and add what? Take your k value, in this case is 1. We're going to add your c value, in this case is what? 1. So 1 plus 1, the first point is 2. Then we do the same thing, but instead of adding c, we're going to minus c. So what's the other foci point? 0. We're going to do the same thing to the vertex, except we don't add or minus c. We do what? Add or minus a. All right. Now, is the x coordinate the same? Yep. So fill that in right away. Okay. Take what and add what? 1, which is your k value. Add 2. So that first vertex is 3, and then take 1 minus 2, so that's going to be. Now look back at your graph. Do these kind of correlate? Yeah, totally. Box those up. Make sure they match. And all right, example 2. Okie dokie. All right, Ali, can you help us read example 2 instruction?
Find an equation for each ellipse. Graph the equation by hand.
Perfect. So graph it by hand, find the equation. So we can always go and plot your vertices since they gave it to us. 1, 2, and 3. 1, 2, and 3. So vertex 1, vertex 2. All right. Where's the center? Yeah, totally. Because the center is the midpoint of the vertices. So 0, 0. Okay. Is it possible to find A? A is from where to where? Center to one of the foci. One of the vertices, I'm sorry. One of the vertices. So, what is the distance? 3. They gave you C. Is it possible for us to find B?
Yes.
Yep. What's the formula? Good. All right. A squared is 3 squared, which is 9. B squared is unknown. C is what? 2. And 2 squared would be 4. So B squared is going to come out to be square root of, 5. And what square root of 5 is your B. Is that cool? All right. How do I know how far to go up or down? A little bit more than what? 2. Yep. In between 2 and 3 is fine. Okay, you got it. Now let's write an equation. Do we have everything we need to write our equation? Perfect. What's h? 0. So can I just write x squared over something plus, what's k? Also 0. So right equals. Okay, what goes where? What's a squared?
Right down
9. So where does that go?
under the X.
Under the X, okay. And that means 5 goes under the Y. Box it up because it did ask for those. Okay, so look at your notes. B and C, we're going to do one together as a class. And then the other one you're going to have to do on your own at the end of a class. So which one would you like for us to go over together? B or C? C? Okay. That means you're going to do B on your own. Here we go. Center is 1, 2. Okay, at least I can plot those. 1, 2, 3, 4. 1, 2, 3, 4. One up 2. All right, I got my center. Focus is 1 up 4. 1. Okay, so that's your center. Here's the focus 1. Oh, whoa. That will give us what right away? 1, 2, what did I write? Oh, dang it, why did I go to the left? You're right. Sorry, 1, 2. 1, 2, and 1, 4. Thank you. Focus 1. That will give us what right away? C. How long is C? Beautiful. And then is it containing another point 2, 2? Right there. Okay, so it's 2, 2. That's perfect. That is directly to the right of the center. So guess what's B? How long is B? B is 1. Yep. Oh, look how nice that is. All right, so I got B on both sides. What else do we need to finish up the graphing? A. A square equals C square plus B square. A square is unknown, so that maintains A square. Well, C square is what, Katie? 4. Good. Dana, B square is what? Good. So guys, A squared comes out to be 5. A is square root of 5. All right, how do we know how far up to plot? A little bit over 2. You're right, from the center. So my focus 1 is already at 2, so I'm going to go a little bit above that and then a little bit below that. Would you guys agree? All right, I have all of the dots. Sketch those like that. Miss my dot, make it fat. There you go. All right, equation. Do we have an H? Yeah, so x minus what? 1 quantity square over something. So, Eve, what's the k value for this question? Good, so y minus 2 square over something. Brayden, this should always equal to what? 1, perfect. All right, Billy, what's a square?
5.
Good, and where should that go?
Under the Y.
Yes, you guys agree, Billy? Yes. Under the x gets what? 1. Yep, you can write a 1 or you don't have to. That's really optional. All right, B, you're going to do that at the end on your own. We'll move on to C. This is, all right, write your own equation for this one. So check it out. How is this position? Vertically, so x minus h quantity square over what? B square. And then y minus k quantity square over a square equals to 1. Okay, you write it in. Find all of those important values. What's the center? Negative 2, 1. Perfect. What's your A distance? Yep. What's your B distance? 2, okay. Check your answer with your friends, guys. And then let me shuffle your deck of cards.
That was hilarious. You say that's why I don't look ugly? So I am not ugly. No. According to everyone else, I'm not ugly. So is it a constant optical equation?
All right, Annika, whenever you're ready, give me the final equation.
Yeah, so you think I'm hot right now.
Okay, take your time, finish it up. So the labeling of the circle, are those correct, by the way? A is 3, B is 2, center is -2, 1. That's all we need, right? Okay.
I got x plus 2 over 25.
X plus 2 quantity square all over.
25.
Remember, A is how far is A? What's the distance for A? Oh, careful. If you're using this by 2, can you see the labeling? This is every 2 boxes, how many units? Every 2 boxes is 1 unit. Can you see that? So. Okay, so A squared is what? 9. Where does it go under? X or Y? Y. True? False? Okay. B is how long? 2. So 2 squared is 4. And it goes right there. Yeah, be careful with the changes in the scaling, okay? All right, Saba, help us read our orbital problem.
The mean distance of Mars from the sun is 142 million miles. If the
Perihelion?
perihelion of Mars is 128.5 million miles, what is the helion? Write an equation for the orbit of Mars about the sun.
Awesome. All right, let's sketch it out. It's your first time, so orbital. The sun is one of the foci. Okie dokie. Here so it says the mean distance. Based on your definition, the mean distance is from the center to one of the vertices. So that's going to be 142. I'm not going to write out 6 zeros, guys. I'm just going to write a big letter N. If you want to write out 6 0, you're more than welcome to do so. So the mean distance is 142 million miles. Perihelion, is that the longest distance or the shortest distance? Shortest. So this right here, how long is that? 128.5 million miles. Okay. Question number 1 says, what is aphelion? And what is that, by the way? What is aphelion? What's the definition? The longest distance. So through the center to the other side of the vertex. So aphelion equals question mark. All right, let's work this out. 142 million. What variable would that be? A, B, or C? A. Is it possible to find B or C straight up? Where is C at, by the way? C is from the center to the sun. Sun, Mr. Golden Sun. All right, C. How do you find C? 142. Take away. Okay, someone crunch a number. Give it to me. 38.5. 13 what? All right, millions? Perfect. We got C. So can we find Aphelion? How do we find that? Add it. Yep. Aphelion equals 142 millions plus 13.5 millions. Someone give me this number, please. 155.5, like that? Yeah. Millions. Okay, so that's in millions of miles. Would you guys agree? All right, box that up. Part 1, done. Part 2, we have to write an equation. Well, like I said, whenever we're doing these, the center, we're going to assume it's at 0, 0 for the sake of simplicity. So we will need x squared over something plus y squared over something equals to 1. As you can see, it is horizontally positioned. So we need to find a squared and b squared. What's the formula to find a squared, b squared? A squared equals b squared plus c squared. Do we know a? Yeah, it's 142 million square equals. We're looking for b, so b squared stays up b squared. What is c? 13.5. Okay, yeah, this is where I do need you guys to bust out your calculator. What's 142 square? Take away 13.5 square. Oh yeah, do it in your head. Okay, 142 square minus 13.5 square. 19,981.75 million miles, right guys? Because all the m's are still there? Yes, no, maybe? Okay, we don't need to simplify this out again. If you want to write out 6 zeros after that, you go for it. But I'm not going to. All right, which one gets the a square? X. So I'm going to write 142 million miles square. And then y square gets the b square. Yeah, so 19981.75 miles is that one. Do I need to square that number? No, because it's already b squared. Box that up. That's an egg roll.